All right, we're going to look right now at solving second-degree trig equations where you are needing to use the square root principle. Now, what I mean by that is, say, an equation like this, 6 sine squared x minus 3 equals 0. That's a second-degree trig equation. It's a trig equation because you have a trig function, the variables within a trig function, but it's second degree because you have sine x and it's squared up here. The trig function itself is squared. Now, if you haven't seen that notation before, that squared on the trig function like that is sort of a mathematician's lazy way to write this. 6 sine x squared, where the trig function is squared. Now, I'm not quite sure when the notation evolved to start writing this without the brackets. I think the idea is that, well, if you write this, this is kind of ambiguous. Is the x squared or is the whole thing squared? So what you probably should do is put the brackets each time, but I guess somehow somebody decided, or it evolved, that let's just put the 2 over here, and then that says you're squaring the trig function. So if you would like to, you write it like that if you want with those brackets, even if you see it written the other way, just to emphasize that that trig function is squared. For solving this, you're going to have to think about equation solving skills that you have from previous. If that's what you're trying to isolate here, ultimately we're trying to find what x is, but first we're going to need to isolate that trig function. To isolate that trig function, since it's squared, we're going to need to use the square root principle. Just think about if it said 6, say, m squared minus 3, and what you'd do, and you do the same thing here, right? If that was just a variable instead of that trig function, well, you'd, start to isolate it, move the 3 over to the other side. 6m squared is 3. Divide by 6 on both sides. M squared is 3 over 6, or 1 over 2. And you'd use the square root of both sides, right? If you want to write it down or not. That. You get m is plus or minus whatever the square root of a half is. Or you could actually, sometimes it's going to be helpful to say that square root of that 1 on top is 1 over, and then square root of 2 will leave it. Then in this case you'd be done, right? That's the solution. Whereas over here, if you follow that same process in isolating the sine, you're going to, you're going to have 6 sine squared x is 3, so sine squared x is 3 over 6, or 1/2, and sine x is plus or minus 1 over root 2. Now that plus or minus is going to be really important here because there's 2 values here instead of just a single value. And it's the same thing here. This is going to be more solutions. Think about where our solutions are. The fact that this is plus or minus, we need to look where sine is positive or negative. Positive or negative. Sine is positive in 1 and 2, so you'd be looking for 2 angles there. Sine is negative in 3 and 4. You'd be looking for 2 angles there. You're actually going to have 4 solutions to this within one full turn, right? Not just 2, because you're not just looking where it's positive and where it's negative. You're looking everywhere here. All right, so you'd go through and find all those angles. 1 over root 2 actually is something where you're going to recognize its reference angle. 1 over root 2 is one of those special angles. It is the reference angle, which is the first solution itself. First solution is the reference angle right there, and you can use that to find the other 3. Those solutions are going to be pi over 4, the reference angle. In quadrant 3, 3 pi over 4, because you're pi minus the reference angle. Pi plus the reference angle is 5 pi over 4. And 2 pi minus the reference angle is 7 pi over 4. In each of those quadrants, there's actually 4 solutions there. So that plus or minus, really important to notice, all right, as you're solving that. Let's look at a few others here. 2tan squared theta minus 14 equals 0. And I didn't write it up above that there's a domain we're looking in, but that's the domain we're looking in here within one full turn. If we're trying to solve this, again, just keep each side separate and isolate that trig function. If 2tan squared theta minus 14 is 0, 2tan squared theta is 14, and tan squared theta is 14 divided by 2, or 7. Tan squared theta is 7. That's going to mean that tan theta is plus or minus square root of 7. And you have to think about where you're going from there. Where we're going from there is, that's not a special ratio. It's not going to be a special angle. We can't use exact values for this, so we're going to have to resort to our calculator. But that's okay, because we're going to find the reference angle by just using that tan inverse function. Again, I would use the positive ratio here, and I would just put it in as square root of 7. Don't put it in as a approximate number, because it's going to be better if you do it this way. Don't round off and then use that rounded off number. Check that my calculator is in radian mode, which it is, and then tan inverse of square root of 7 gives me that. Now I got to find 3 other angles, so I'm going to store this as, say, x on here, because then I can just punch in a few things all in a row here without having to re-enter that number. I'll go back to this picture for a second here. I'm going to write that we'll write that one down. If we're doing 2 decimal places, that was about 1.21. But on our grid over here, if we're looking for where this is, we're looking in all 4 quadrants. We're looking for 1 there, 1 there, 1 there, and 1 there. There's 4 angles. If we're going to draw them, we're looking for that one, that one, that one, and all the way around to there. So we need to, in quadrant 1 is the reference angle. In quadrant 2, we got to go pi minus the reference angle. In quadrant 3, we're going to go pi plus the reference angle. Quadrant 4, we're going to go 2 pi minus the reference angle. All right, so let's go back and do that and find all of them. So I need, in quadrant 2, I need to find pi minus that reference angle. Quadrant 3, I need to find pi plus that reference angle. And in quadrant 4, I need to do 2 pi minus that reference angle. And I'll have my four answers there, except for one's off the screen already, but I already wrote it down. We have 1.93, 4.35, 5.07. So that was 1.93, 4.35, 5.07. So those are my solutions, the 4 solutions there, because there's 1 in every quadrant, because that plus or minus. All right, let's do one last one down here. All right, let's look at one last one here. We're looking for where 3 secant squared x minus 4 equals 0. And so in starting to solve that, I would say a good first step is to make it into 3 secant squared is 4. Or in other words, secant squared x is 4/3. I would leave that as a fraction instead of trying to write that as an approximate decimal, because it's going to possibly work out to an exact value, which it will in this case. In a second you'll see. If secant squared is 4/3, secant of x is plus or minus the square root of 4/3. And it's actually going to be helpful to write this as, instead of square root of 4/3, you can actually write the square root of the top number. So we can write this as plus or minus 2 over root 3, right? That's better, because that is starting to look like one of those special ratios, which it is. And it might be easier to see if you write it as cosine, right, in terms of one of the primary ratios. If secant is 2 over root 3, cosine is root 3 over 2. It's still plus or minus. Now, that again, you need to recognize that that's one of those special ratios from one of the special triangles, and get the reference angle that way. That's that triangle, that 30, 60, 90 triangle, where you have, looking at it that way, because we want the cosine to be root 3 over 2, so it's going to be that, right? Adjacent over hypotenuse there, root 3 over 2. So it's going to be this smaller angle, this pi over 6, 30 degrees. So that's our reference angle. Reference angle is pi over 6. So then when you're looking for solutions to this, that's going to be our first solution. It is plus or minus, so it's going to be in every quadrant. You're going to have an angle there, and there, and there, and there. Right? You're looking for each of those. That first one is the reference angle. So if we're writing the solutions here, first solution is pi over 6. Second solution is right around to there, pi minus the reference angle. So pi minus pi over 6, 5 pi over 6. And then one after that, we're going over here. We're going to have pi plus the reference angle. So 7 pi over 6. And then we have our one all the way over to there. Diagram's starting to get crowded, but that's okay. 11 pi over 6. So all four of those angles, one in every quadrant, again, because of that plus or minus. All right? So that is solving trig equations where you need to use the square root principle. Second degree trig equations that have the trig function squared, you're going to need to use this. All right? That's it.